Okay, this is Marcy Kinzer, and welcome to RGES Algebra 2, Lesson 33B, Part 2. We're reviewing for the final exam, and this will be the review of Chapter 7. So, we're doing powers and roots. When we're looking at powers, there are certain basic things you care about. Any number, to the first power is going to equal the same number. Any number to the zero power is going to equal 1. 0 to any power, 0 times 0 times 0, doesn't matter how many times, will always equal 0. And 1 to any power will always equal 1. Right, because 1 times 1 times 1 times 1 doesn't matter how many times, will always equal 1. So these are my 4 basic rules. Special rules. These are the special rules. Okay. Anything else when I raise it to the power, let's say I raise this to the third power. What I'm really saying is I have x times y times z times z times z, and I take that whole thing 3 times. So how many x's do you have? 6. I can also view that as a multiply. How many y's do you have? 3. I don't care. You could write it out for all I care. Okay? So if it's not obvious to you, write it out. This means that I have just one y. 1 times 3 is 3. How many z's do I have? Well, I have 9. I have 3 in the first term, 3 in the second term, 3 in the third term. That's multiply. So that would be 9 of those. And that's the answer. So if you have a negative 6, a squared, b to the third, c to the fifth, and I'm raising it, the whole thing squared, that means my negative sign has to be squared. Well, that'll make it positive. 6 has to be squared. That'll be 36, 6 times 6. A squared 2 times, would be multiply a to the fourth. B to the third, or 3 b's, 2 times would be b to the sixth. And c's, I have 5 of them 2 times, or 5 times 2 is 10. Sorry, I should write that better. And that's all there is to this. So I would want you to be able to do these problems. If I had something like ab to the x power, that would be the same as multiply. This is like a to the first. Maybe I should even just do it that way. A squared b. This would be a multiply to the 2x, b, 1 times x is x. Looking for any other examples you might need. Hang on 1 second. I also need you to review the binomial theorem on 7.2. Recall the basic idea. The a's will start with the fourth power and go down each one till you get no a's in the term. And the b's will start with the fourth power on the right-hand side, or start with the no power, and then go up each time until you get b to the fourth in the last term. You're going to have 5 terms, one more than this. My first term again will be a to the fourth. My last term will be b to the fourth. Okay? Because it's a negative, I will start with a negative, and then I'll go positive, then I'll go negative, then I'll go positive. Okay? And so I'll have a to the third b plus a squared b squared minus a b cubed plus b to the fourth. And then I only have one more thing to do. I have to plug in my constant. There is no constant in the first and last term unless I have a constant in my original problem. Okay, so I'm going to look to the previous term. I'm going to take the exponent times the constant. 4 times 1 divided by the first term. Remember that? 4 times 1, and it's the first term. 3 times 4, and it's the second term. That's 12 divided by 2, sorry. And that will be 6. That goes in the third place. 6 times 2 divided by 3. And that would be 12 divided by 3 gives me 4. 4 times 1 divided by 4. 4 times 1 divided by 4. And that'll give me 1 for my last term, but I know that there's no constant there anyway. So that's probably the one I'll pick for you. In other words, something that just has variables. Let's practice one more time then, since I won't make it too complicated. Okay? Let's say I had x plus y to the 6th power. I'm going to have 7 terms when I'm done. Ready? Here we go. X to the 6th. Add, always add, unless it's a subtraction, then you're going to alternate. But if it's addition, you don't alternate first plus then minus, you just keep them all addition. Okay. 6 times 1 divided by 6 is 6. X to the 5th, y. 30 divided by 2 is 15. X to the 4th, y squared. Are you seeing it? 4 times 6 is, 4 times 15 and divided by 3. That would be 20. That's going to be my next one, plus 20. My x terms will be down 1. My y terms will be up 1. Plus 20 times 3. It's my 1, 2, 3, 4th term. That'll be 15. My x's will be down 1. My y's will be up 1. Plus 15 times 2. It's my 5th term. That'll be 6. My x's will be down 1. My y's will be up 1. The last one will be, there'll be no constant, but prove it to yourself. 6 times 1, it's my 6th term. Okay, so no constant, there's no more x's, y to the 6th. And that, all of that, with all of that is your answer. If you can do one of those, I'll be happy. Let's look at the next idea. I'm going to ignore 7.3 for purposes of the exam. 7.4, we're talking about roots, and we're going to ignore the idea of positive and negative roots and when to choose them for right now. That's okay, we'll just work in terms of principal roots, which means always choose the positive one. It's principal with an AL, yeah. Principal roots. Okay, so that means always give me the positive answer. So if I just had the square root of 121, you would know that that is 11. You should have the numbers memorized through 13. Okay, so the square root of 169 is 13, and that'll be the highest one I'll go with as far as numbers. Unless you have to, as far as to have memorized, you should have all those memorized if you don't already. Now, if you anything higher than that, you'll want to use breaking it down into its primes. So first we'll look at something with just variables. A to the 4th, b squared, c to the 6th. We're taking the square root. If there's no index number, that always means the square root. And so you could have put a 2 in there, but it's not necessary. And what I'm going to do then is divide by 2. Every exponent divide by 2. If I can't divide all of these by 2, I can only take out the ones I can divide by 2. What do I mean by that? 4 divided by 2 is 2, so that's the same as a squared outside the radical. 2 divided by 2 is 1, so that's the same as b outside. And this is the same as 6 divided by 2, or 6 cubed outside the radical. But if I have something where they did not all divide evenly, let's say instead I had, looking for something here. Let's say instead I had, let's do a cubed root instead, and I'll get a to the 9th, b to the 12th, c to the 13th. What happens there? Well, 9 divided by 3 is 3. B, 12 divided by 3 is 4. For c, what's the number that goes in evenly would be a 12. So I have c to the 12th times c. You could think of it that way. 12 divided by 3 is 4, but I still have 1 under the radical. Don't change your index, and this is c. If you have numbers and variables mixed, not a problem. Well, let's think about 16 for a minute. 16 equals 2 times 8, which is 2 times 4, which is 2 times 2, and I need at least 4 to bring it outside, but I have 4 2's. 8 for my a's, 8 divided by 4 is 2. For 81, it's the same idea. It's 9 times 9, which is 3 times 3 times 3 times 3. I have all 4 that I need, so I'll bring 1 out. And 4 divided by 4 for my b's is that. So that equals that. And hopefully that these are simple ideas at this stage for you. Now, let's look for more complex ideas. Actually, a lot of the things you learn to do with exponents and roots are in Unit 8. So just for Unit 7, there's really only one last idea that I will test, and that has to do with Pythagorean's theorem. Recall that this is the hypotenuse, and the other two sides are called the legs of a right triangle. The hypotenuse is always the longest length, and it's opposite the right angle. The basic theorem says c squared equals, which means always is the hypotenuse squared, is the sum of the squares of the other two sides. C squared equals a squared plus b squared. So this allows me to use radicals, okay, because if I say b, let's say, is 5 and a is 7, I could ask you, what is the hypotenuse? And you'll say, okay, well, c squared equals 7 squared plus 5 squared. Combine, you're going to get 60, 74. And so c equals the square root of 74. Something like that. Okay, 74, that would be 2 times 37, and that doesn't simplify. Always check, because if I had something else, I might have had something that simplified, so always check that. Okay? In other words, if I had 2 times 2 times something, then I would have pulled out a 2. All right? So you should be comfortable enough with that stuff. Go ahead and review. A good way to review 6 and 7 then is to look at your Test 6 and all the quizzes that relate to Chapter 6 and 7. And if you still need review, you could either go back to the book or go back to previous tapes to get extra review. You can tell perhaps, but I'm telling you, I'm very willing to tell you that the problems I choose will be simpler problems, not more complex problems. Okay, that's important to me because I want to know that you know the main ideas. So you won't get as startled up in complicated manipulation where you have lots of ways you can make the mistake. I want to make sure you understand the basic ideas. Do check over some word problems because we will have word problems on the exam. We'll have word problems over every section. So check out some of, again, the simpler word problems, the ones I emphasized as we went over things. Okay, review, and we'll be back next week to look at the last chapters together before you take your exam.